simplifying algebraic fractions. So here we're going to look at simplifying algebraic fractions. Now we're going to look at two types of algebraic fractions as such. One's like here, where the denominator is a whole number, or as you'll see on the far board here, one's here, where the denominator is an expression. Now I'm going to be working on two different kind of methods or techniques you can use to find your answer. However, what I always say to students is work with what you're comfortable with, what you know, and maybe what you've been doing since first year. So let's get started. Now in your notes on page number 39, you're going to see this. So I'm going to get you to pop over to page 39, and actually across the page, we're going to be looking at exercise 5.1, and we're going to work with part A. But if you are using the notes, guys, just so you know, on 39, you have a full blank page, and we're going to look at two ways to attempt the same question here. So let's get started. Simplifying algebraic fractions, to me, what you're actually being asked to do is to write these fractions, add them together, and write them as a single fraction. So method number one. Method number one, I like to refer to as my lowest common multiple one, okay? Not the best, terminology there, but my LCM. What do I mean by this? Basically, what I want you to do when you see two fractions where the denominator is a whole number, 2 and 4, I want you to find their lowest common multiple. Basically, what will both of them divide into evenly? 2 will go into 4, 4 will go into 4. So, in this case here, the lowest common multiple of 2 and 4 is 4. Now, in an exam, if this was the question, most likely this will be awarded low partial credits, which actually means just by writing LCM at 4, you get low partial credits. You have marks. So what do we want to do, or how do we utilize, or use, I should say, this lowest common multiple? Well, what we want to do is we want to multiply both of these fractions by this lowest common multiple, which is 4. But also we want to divide these two fractions by that lowest common multiple, which is also 4. Here, 2 into 4 goes twice, and here, 4 into 4 goes once. Now what you're already seeing happen here is you're already seeing it being written as a single fraction. So what actually do we have here now? We have 2, bracket 2a, minus 1, plus 1, bracket 6a, minus 12. This is all over my lowest common multiple, which is 4. So we multiply both fractions by 4 and then divided the whole lot by 4. Again, multiply, divide are the inverse of each other. From here, it's written as a single fraction, so all we want to do is we want to simplify it. So let's remove our brackets. We have 2 times 2a and 2 times minus 1. 2 times 2a is going to leave me with 4a. 2 times minus 1 is going to leave me with minus 2. On the far side, we have 1 times 6a and 1 times minus 12. 1 times 6a is plus 6a, and 1 times minus 12 is minus 12. Remember, anything multiplied by 1 is itself. This is all divided by the denominator of 4. Final step, usually, maybe not here, we add up our like terms. We have 4a and plus 6a. We have minus 2 and we have minus 12. So here we have 4a plus 6a is going to leave me with 10a. Running out of space, I might just come up over as far as here, guys. I can put a line in a second. Is going to leave me with 10a. And minus 2 minus 12 is going to leave me with minus 14. Again, this is all over my denominator of 4. Now, you might look at that, and I'm going to do this just a very quick way. I'm not going to show every little step. And you might say to yourself, Tracy, I can simplify that slightly further. Because if I look at 10, 14, and 4, each of them are divisible by 2. So actually, if I want to go that a little bit further, simplify it down, we're going to divide 2 into each. It's kind of like finding a common multiple. 2 into 10 goes 5 times, so I'm left with 5a. 2 into 14 will go 7 times, and 2 into 4 will go twice. So if I want to simplify it down fully, here's my answer. Now that's method number 1, and that's using my lowest common multiple of that denominator, or of those denominators, to find a single fraction and simplify it down as small as I possibly can. A little bit of factorization technically there, but I didn't want to dive too deep on that. On the far board here, or on the far side of this board, we're going to look at a second method. And this method I also refer to as the crisscross method. Basically, where we multiply the denominator by the opposite numerator, denominator times the opposite numerator, and finally, denominator times denominator. Now, both methods will achieve the exact same result or the exact same answer because really they're doing the exact same thing. One's just slightly longer than the other. So in this case here, we're going to multiply our denominator by the opposite numerator, denominator by the opposite numerator. We'll do that step first. So here we multiply 4 by 2a minus 1. Plus is in the middle, and 2 times 6a minus 12. Now this is all over denominator times denominator, or bottom times bottom. 2 times 4. So opposite denominator by the opposite numerator, and denominator by denominator. Bottom times top, bottom times top, bottom times bottom. Kind of like a tongue twister. Now, in this case here, same idea applies, we multiply out. We're going to say 4 times 2a and 4 times minus 1. 4 times 2a is going to leave me with 8a. 4 times minus 1 is going to leave me with minus 4. On the far side here, we have 2a. 2a times 6a and 2a times minus 12. 2a times 6a will give me plus 12a. 2a times minus 12 will leave me with minus 24. And this is all over 2 times 4 is 8. Notice the denominator is a lot bigger, or larger number, than the far side. Here, let's add up my like terms. Everything with an a, and my numbers. So, 8a plus 12a is going to leave me with 20a. Minus 4 minus 24 is going to give me minus 28. And this is all over 8. Now, again, same idea applies as before. Can we simplify that down? Here, I'm now left with 28, just copy and paste, minus 28, all over 8. Can I simplify that down ever so slightly more? Not going to do step by step, but is there a number? What's the biggest number that will divide into 20, 28, and 8? 4. 4 into 20 will go 5 times, so I'm left with 5a. 4 into 28 will go 7 times. And 4 into 8 will go twice. So what we see happen here is we have the same answer no matter which of the methods you choose to use. I always say to students, choose a method. Now, that's the first type of simplifying fractions where the denominator is a whole number. But let's take a look at when the denominator is actually an expression. Jump over as far as page number 41, and we're actually going to be attempting 5.2 on page number 42. So, part A, exercise 5.2. Here, what you're noticing is the denominator is not a whole number. It's an expression on either side. Now, there's 2 methods we can use here, but the crisscross method is usually my preferred method in this case. However, entirely up to yourself, whatever you are comfortable with yourself. I'm going to start off though with the lowest common multiple. This time it's not the lowest common multiple, it's just a common multiple. So, same idea as before, we look at the denominators and we say to ourselves, 2x plus 1, 2x minus 1. What will they both divide into evenly? Now, usually you look for the lowest common multiple, but it'd be quite difficult here. So instead, we're just going to find a common multiple of the 2. Here, 2x plus 1. Doesn't look like a 1, but it will. And 2x minus 1. Multiplied by each other will be a common multiple. So what I'm going to do is the same idea as before. It's a little bit more long-winded. I'm going to multiply both sides here by this common multiple, i.e. 2x plus 1 times 2x minus 1. Same on this side. 2x plus 1, 2x minus 1. And what I'm then going to do is the same idea as before. I'll divide it all by 2x plus 1, 2x minus 1. So I'm multiplying both sides by the denominators and dividing. 2x plus 1 goes into 2x plus 1 once, 2x minus 1 goes into 2x minus 1 once. So what am I actually left with here? I'm left with 5 times, I like to put my whole number out in front, times 2x minus 1. Plus in the middle, 4 times 2x plus 1. And this here is all over, and I'm not going to multiply these out. Leave it as factors. 2x plus 1 times 2x minus 1. Move my little minus sign down. Now, you're nearly done. Same idea as before. Let's tidy up the numerator. So let's multiply out. 5 times 2x, 5 times minus 1. 5 times 2x is going to leave me with 10x. 5 times minus 1 is minus 5. On the far side here, we have 4 times 2x and 4 times 1. 4 times 2x gives me plus 8x, and 4 times 1 is plus 4. This is all over. Copy and paste the denominator here. 2x plus 1 times 2x minus 1. Copy and paste the denominator, nothing changing. Finally, let's add our like terms. 10x and 8x minus 5 and plus 4. 10 plus 8 is going to leave me with 18x. Minus 5 plus 4 will leave me with minus 1. And this is all over again. 2x plus 1. 2x minus 1. And that there is my answer. Now, you're probably noticing here, and if you've done this quite recently, or if you're very comfortable, you might be interested in going, Tracy, it's just denominator times numerator, denominator times numerator, denominator times denominator. It 100% is, okay? However, some students, when they use the lowest common multiple method on the far question, they like to use something similar here, or at least have a similar system in their mind. This is what I'd always be thinking of. In this case here, let's use our crisscross method. Denominator times numerator, denominators times numerator, and again, denominators times denominator. So again, you're going to look at it and you're going to be like, they're identical, Tracy. Yes, they are. So here, we're going to multiply the denominator times the numerator, denominator times numerator to start off. So we're going to have 5. 5 times the opposite bottom, which is 2x minus 1, plus in the middle, 4, bracket 2x plus 1, all over, and again, bottom times bottom, or denominator times denominator, 2x plus 1 times 2x minus 1. Now you'll look here, you'll say, Tracy, they're identical. So we know this will work out the exact same, which is 18x minus 1 all over 2x plus 1, 2x minus 1. Both answers will be the same, no matter what way you think about it. And again, technically the exact same technique. Guys, that is simplifying algebraic expressions.